Hey everyone, what's up? Welcome back to Tech Curiosity Stream. Today, we're diving deep into a topic that might sound a little bit technical, but trust me, it's one of the most important conversations happening in the tech world right now. It affects how your favorite apps are built, how they run, and why they sometimes crash right when you need them most. We're talking about Monolith versus microservices. It's a debate that shapes the digital world we live in. From the biggest tech giants like Netflix and Amazon to the smallest startups trying to build the next big thing. So, if you've ever wondered what goes on behind the scenes of the software you use every single day, you're in the right place. Now, you might be thinking, why should I, as a user or even a junior developer, care about this? That's a fair question. The answer is simple. This isn't just some abstract concept for senior architects. The choice between a monolithic and a microservices architecture has a huge ripple effect. It impacts everything. Before we get into the nitty-gritty of it all, if you're new here, make sure you hit that subscribe button and ring the notification bell. We drop videos like this all the time, breaking down complex tech topics to feed your curiosity. Let's start by setting the stage. The term monolith sounds kind of ancient and imposing, like a giant stone structure from an old movie. And honestly, that's not a bad way to think about it. In software terms, a monolithic architecture means the entire application is built as a single, indivisible unit. Every single function, every feature, every piece of code is bundled together into one massive program. Imagine that e-commerce website we talked about. In a monolithic world, the code that handles user logins, the code that displays product pages, the code for the shopping cart, and the code for processing credit card payments are all living together in the same house. Think of it like a classic Swiss Army knife. You've got the main blade, the can opener, the screwdriver, and the tiny scissors all folded into one convenient handle. It's super handy to have everything in one place, right? So, when a developer works on a monolithic application, they typically check out the entire code base onto their machine. The front-end user interface, the back-end business logic, and the data access layer are all part of the same project. When you want to deploy a new version of your app, you take this one big file and you push it to your server or servers. The process is simple. You stop the old version, copy the new version over, and start it back up. This approach has been the standard for a very long time for a reason. It's straightforward. When you're just starting out, it's often the simplest and fastest way to get a product up and running. Everything is in one place, which makes it easier to develop, test, and deploy initially. You don't have to worry about the complexities of different services communicating with each other, because they're all part of the same program. The absolute number one advantage is simplicity. When you're starting a new project, especially with a small team, simplicity is your best friend. With a monolith, you have one code base, one development environment to set up, and one application to deploy. Another major pro is performance, at least in a certain context. Because all the components of a monolith run in the same process, communication between them is lightning fast. It's just a simple function call within the same memory space. Since everything is in one place, it's incredibly straightforward to write and debug code. You can easily trace a request as it flows through the different layers of the application, from the user interface down to the database, all within a single IDE. Now for the other side of the coin. That beautiful simplicity we just talked about, it has a shelf life. As a monolithic application grows in size and complexity, its initial advantages can morph into massive disadvantages. The single, unified codebase that was once so easy to manage becomes a beast. Over time, with many developers contributing code, the boundaries between modules can blur. The code becomes a tangled web of dependencies, making it incredibly difficult to understand and modify. Making a small change in one part of the system can have unforeseen and catastrophic consequences in a completely different area. This complexity directly impacts developer productivity and makes deployments terrifying, week-long processes. One of the most significant challenges with a monolithic architecture is scaling. When your application starts getting more traffic, you need to be able to handle the increased load. With a monolith, you have only one way to scale the entire application. Let's go back to our e-commerce example. Imagine it's Black Friday. The product browsing and shopping cart features are getting hammered with traffic. but the user profile update page is barely being used. With a monolith, you can't just scale the parts of the application that are under heavy load. So, after seeing all the challenges that come with a massive, aging monolith, the tech world was desperately searching for a better way to build complex, large-scale applications. The answer that emerged, and the one that has dominated tech conversations for the past decade, is microservices. This isn't just a minor tweak, it's a fundamentally different philosophy for designing software. Instead of building one giant, all-encompassing application, the microservices architecture advocates for breaking it down into a collection of small, independent, and loosely coupled services. Let's revisit our trusty e-commerce application. In a microservices world, you wouldn't have one big program. Instead, you'd have a separate service for user authentication, another service for the product catalog, a dedicated service for the shopping cart, and yet another for payment processing. Think of it like a modern kitchen full of specialized appliances. You have a refrigerator, a microwave, a blender, and a coffee maker. Each one does its job exceptionally well, and they are all independent. If your blender breaks, you can still use the microwave and the coffee maker. So, if these services are all separate little applications, how do they actually work together to create a cohesive user experience? The answer is communication, but not the direct, in-memory function calls we saw in the monolith. In a microservices architecture, services communicate with each other over a network. Because services only interact through these formal API contracts, the internal implementation of a service can be changed at any time without affecting the other services, as long as the API contract remains the same. This autonomy extends to technology choices. Unlike a monolith, where you're locked into a single tech stack, microservices allow for what's known as polyglot development. The team building the payment processing service might choose to use Java because of its robust security libraries. Of course, this distributed nature introduces its own set of challenges. You now have to worry about things like network latency, service discovery, and fault tolerance. These are complex problems that require a more sophisticated infrastructure. The absolute number one advantage is improved scalability. This is the big one. Because each service is independent, you can scale each one individually based on its specific needs. If your video streaming service is getting hammered with traffic, but your login service is just ticking along, you can allocate more resources only to the streaming service. Next up is enhanced resilience and fault isolation. In a monolith, one misbehaving component can bring the whole ship down. Microservices create bulkheads, just like in a submarine. If one service fails, it doesn't automatically cause a cascade failure across the entire system. Finally, and this is a big one for large organizations, is team autonomy and faster development cycles. Microservices allow you to organize your engineering department into small, focused teams, each owning one or more services. These teams can work independently and in parallel. Of course, it's not all sunshine and rainbows. The microservices architecture is powerful, but that power comes at a cost, and the primary cost is a massive increase in complexity. While each individual service might be simple, managing the entire distributed system is a whole different beast. Then there's the issue of data consistency. In a monolith, all your data lives in one database, and you can rely on database transactions to keep everything consistent. In a microservices world, how do you keep them in sync? This leads to complex patterns and is a common source of subtle, hard-to-fix bugs. And let's not forget about testing. Testing a monolith is straightforward. You run the application and test its functionality end-to-end. How do you test a system composed of 50 different services? End-to-end testing becomes a nightmare. So, we've been on quite a journey. We've explored the straightforward simplicity of the monolith and the complex, powerful independence of microservices. Now we arrive at the big million-dollar question. Which one should you choose? The honest, slightly frustrating answer is, it depends. There is no single best architecture. The right choice depends entirely on your specific context, your team, your product, your timeline, and your goals. Despite all the hype around microservices, starting with a monolith is often the most pragmatic and intelligent choice, especially for new projects, startups, or small teams. When you're in the early stages, your primary goal is speed and learning. The transition doesn't have to be an all-or-nothing, big bang rewrite. A much safer and more common approach is a gradual migration. This is often called the strangler fig pattern, where the new services slowly grow around the old monolith, gradually taking over its functionality. It's also important to remember that this isn't a strictly binary choice. Many companies find success with a hybrid approach. They might keep the core of their application as a well-structured monolith while spinning off specific high-scale features into true microservices. So, what's the final verdict? The key takeaway is to be intentional. Understand the trade-offs. The best architecture is the one that solves your current problems and allows you to move forward effectively, without prematurely optimizing for a future you can't predict. And that's a wrap on our deep dive into monoliths and microservices. I hope this breakdown has helped demystify these concepts and given you a clearer picture of why this debate matters so much to everyone in the tech world. If you found this video helpful and want to keep feeding your curiosity about the tech that shapes our world, make sure you're subscribed to Tech Curiosity Stream and that you've hit that notification bell so you don't miss our next video. Let me know down in the comments which architecture you've worked with or which one you think is more interesting. I read as many comments as I can, and I'd love to hear your thoughts. See you in the next video. Until then, stay curious.